Okay, so we have here the specimen labeling and requisition. So we have here the proper way of labeling a specimen. So the specimen label should eventually put on the container itself on the body of that, not on the cover or the lid. So the specimen label should contain the following. It contains here all the complete patient's information. This includes here the name, the identification number. We have also the room number. We have here the physician. The culture site is very important. Okay, you need to indicate here where is the anatomic site or what anatomic site did you collect the specimen. Then of course here the date and the time of collection should also be indicated. Okay, then we have also here the requisition form. So requisition form, request form, only that although we are not the one doing the requisition form here, so but then the requisition form should bear the following information. So should also contains here the patient's name, the age, the gender, patient room number, location, physician's name, address, specific anatomic site where they wanted to collect the specimen. We have also here some date and time of the collection. Okay, then we have here for the safety. So when we are transporting the specimen, you need to put at one a container or the collection tube should put here in your biosafety or in the biohazard pouch. So meron siya dapat na, di ba, have you seen the biohazard na symbol? So dapat naka-indicate or naka-ganon ang plastic na container natin. It should be leak-proof na container. Leak-proof here, so that's to prevent the drying up of your specimen. Okay, next we have here the specimen storage. Okay, so if there's delay in the transport of the specimen or delay in the processing of the specimen, okay, then you can store the specimen at the different temperature here. So before you try to process that one. So first one, you can store the specimen here in the refrigerator temperature for the following specimen. So we have here the foreign devices, like for example, your Polycat, mga ganon. Second one, we have here the CSF for your viral isolation. We have also here your swab, your sputum. And we have also here for the unpreserved na mga urine and your fecal sample. Unpreserved means say wala silang chemical preservative. Okay, however here for the delay, like in the case for example for your fecal sample for the diagnosis of your Clostridium difficile, you can put your fecal sample in the transport medium here, which is the Carib-Blair. It's a transport medium here for the isolation of your Clostridium difficile. Or if there's delay in the processing, like more than 3 days pa siya i-process, then you need to frozen the specimen at negative 70 degrees Celsius that would try to preserve the viability of your microorganism. On the other hand, the following specimen, on the other hand, could be stored here at room temperature prior to the processing. So you could have here the abscess or wound, lesion. So dapat nasa room temp lang sila. Never ever refrigerate this one. You have also here the different body fluids, respiratory specimen, including your oro, your OPS, NPS, throat swab, mga ganun. And the preserved na urine on the preserved na stool sample here is being stored here at the room temperature. Urine can be preserved here by addition of your boric acid. In the case of your fecal sample, you can preserve that one. But the fecal sample here for na may preservative siya is for identification of your ova and parasite. That's for your parasitology, not for your culture. Okay, so you can add formalin for that. You can add also here your polyphenol chloride. Then we have the CSF for your bacteria, for identification of the bacteria in the CSF. Pero pag CSF ang sample natin, wherein we are identifying the virus here, so dapat naka-ref siya. But just like when you're identifying here your Mycobacterium tuberculosis, the CSF in the case of your Mycobacterium tuberculosis, or either cause of agent of your pneumonia, meningitis, then dapat naka-room temperature siya, which are your bacteria. Okay, then we have here the different anticoagulants used here for the preservation here of your specimen. That's primarily to prevent here the clotting of your blood for the blood culture or even your synovial fluid or peritoneal fluid. So the coagulant used here most likely for our blood culture is in the form of the SPS. Again, this is sodium polyanitosulfonate. Mali yung kanina. Okay, at the concentration at 0.025%. Okay, more than 0.025% the concentration that is toxic to your Neisseria or even to your anaerobes. Heparin, on the other hand, is used here for the recovery of your anaerobes and your Mycobacterium tuberculosis. For the case of the EDTA and the citrate, they are not usually used anticoagulant here for the bacterial culture, but it's being used for the nucleic acid viral DNA analysis. Okay, then we have here the holding transport media. So they serve here as a temporary transport media where you can inoculate your specimen from the bedside, collected from the bedside. But then again, if they are in the transport media, upon receipt to the laboratory, you still need to inoculate from this media your specimen to your selective na mga media or your general isolation media or selective na media. So we have the steward, we have your amis. Sometimes you could have here incorporated with the charcoal. Example na may charcoal, we have here the culture media na Bordegengo. So this is used here for the recovery of your Bordetella pertussis, the causative agent of your wolfing cough. Then we have also the commercial system, the GEMBEC, the James E. Martin Biological Environmental Culture System. So it's commercial system. So this provides here anaerobic environment even for your Neisseria gonorrhea. Okay, then we have here the specimen priority. So we have here the level of the specimen here. So this would allow you then to determine here which specimen is eventually should be processed first or immediately compared with the others. So level 1 specimen is label here as critical or the invasive na specimen. Pag sinabing critical, it's a critical here because the bacteria isolated from this type of the specimen are very life-threatening. So, na kailangan na natin na ma-process agad para malaman agad kung positive siya or negative. So, pag na-positive, so nanganganib, life-threatening ito sa life ng ating patient. Another one is invasive because this specimen would eventually came from an invasive procedure na hindi natin, we can't afford na masira or masayang ang specimen natin. Like for example, we have the CSF, amniotic fluid, blood, pericardial, brain, heart valve. So ito, mga invasive procedure ito. So we can't afford na mag-collect pa ulit ng specimen for this one. That's why dapat ma-process agad in order for you to recover the bacteria or the microorganisms. Level 2, on the other hand, pertains to your unpreserved na specimen. Unpreserved, so they are prone to degradation, and they're also prone here to your normal microbial multiplication. They are unprotected. So, madali silang masira. This includes specimen here, like for example, we have your body fluids, we have your wound drainage, your abscess, we have your tissues, we have your bones. And we have here bones, we have here also your sputum. The third one, our specimen here, level 3, are specimens which require here quantitation. So, kailangan natin magkaroon ng colony count for you to have here to quantitate the bacterial count. Example, we have the urine culture, we have also here the tissues. And the level 4, on the other hand, pertains here to the preserved specimen. So, preserved with the boric acid or preserved with the formaldehyde. Okay, and this one, since naka-preserve siya, most like this one is being transported or incorporated with your transport media. Ano sila sa transport media natin? When you receive the specimen na preserve, okay, so pag naka-receive ka nito, level 1, saka versus level 4, anayin mo si level 1. Okay, pero pag ito na-receive mo, okay, since na alam mo na, okay lang yan kasi naka-preserve naman siya, pero wala kang ginagawa. Wala ka namang trabaho, so wag mo nang isipin na since naka-preserve na, okay, cool ka lang, okay, hayaan mo na muna yan, ganyan. Ayaw mo kasi, wag kang, parang katamaran na yon. Kung wala ka namang ginagawa, you process, di ba? Kung ito lang ang specimen mo, okay, wag mo isipin na since naka-preserve siya, okay, hayaan mo na, mamaya na yan. No, you need to process it then, pag wala ka namang ginagawa. But if you receive specimen na may mga ganito, saka ito, so this would serve here as your basis. Which one you're going to process first, which one is okay, require or can wait for the processing, something like that. Okay, we have here the grounds here for rejection of the specimen. The first one, we have here unmatched requisition slip with the label of the specimen. So, we're not sure kung alin ang tama doon. So, reject. The second one, we have here the specimen not properly preserved or the specimen is already more than 2 hours without the preservative or the specimen has not been stored in a proper incubation temperature or storage temperature. The third one, we have a questionable source of the specimen like your folic acid. Okay, then we have also the QNS quantity not sufficient. So we have the leaking specimen, we have a dried up na specimen, so most likely wala tayong ma-recover na microorganisms. Then for number 5, we have the sputum exam, so versus your saliva. Sputum here, if the sputum like for example would have here less than 25 na WBC, and sobrang dami ng squamous epithelials, that's more than 10, so that will signify that this one is a saliva, not your sputum. You could identify that one when you perform here your gram stain. Nakikita mo siya. Okay, then we have here the macroscopic observation. Okay, so upon receipt of the specimen, so you need to take note of the following. Number 1, okay, ano ang na-receive na specimen? Is that a swab? Is that an aspirate? Is that a body fluid? So you need to indicate that one with your result form. Another one, with the stool sample here, you need also to indicate the consistency. Is that a form stool? Is that a watery? Is that would have the mucoid? Okay, so dapat naka-indicated siya. Third one, you should also try to take note for the presence of the blood, the mucus, the presence of, we have also here the sulfur granules, okay, mga distinct na characteristic odor. So, ang mga ito, it might signify that what you have are the anaerobic na organisms. Number 4, try to indicate also here the volume. Ilang volume you should be indicating that one with your result form. And number 5, we have here for the fluid, like mga body fluids natin, you should indicate also, is that a clear, is that a cloudy, is that turbid. Again, it will help here in the proper interpretation of your results. Okay, then we have here your microscopic observation. So your microscopic observation here would help you guide some important important things. Okay, so when you're doing your gram stain, so it could help here. Number 1, again, to determine here the quality of the specimen, di ba? For your sputum ulit, dapat ang sputum natin ay more than 25 na WBC and less than 10 na squamous epithelial cells. But if you're severe na less than 25 na WBC, more than 10 na squamous epithelial cells, so what you have will be your saliva. So again, if the specimen is intended to submit a sputum, the sputum hindi sa saliva. Okay, next here, gram stain result will give you an early indication of the patient condition. Like for example, gram stain result, we have your gram-positive diplococci. So it might signify the presence of your strep pneumoniae. So although hindi pa tapos lahat ng test mo, like your culture and sensitivity, including your biochemical reactions, hindi pa siya tapos, you can release here ang initial gram stain result. So the initial gram stain result would provide information to the patient, or to the physician, I mean, of what might have you recovered with the specimen. And therefore, pag nakita na, okay, so strep pneumoniae because of this characteristic under the gram stain result under the microscope, the physician could start giving an antibiotic for that. So pag lumabas ang result, kung ano ba talaga na-identify at hindi siya strep pneumoniae, so it can shift to other antibiotic naman. At least, they have started already antibiotic treatment with your initial gram stain result. Okay, the third one, it guide here the workup of the specimen for the culture. So like for example, you happen to identify like may mga foul-smelling odor, may gas, may sulfur granules, something like that. It might signify the presence of your anaerobes. And therefore, okay, instead the usual na mga culture media, so mag-add ka ng mga additional culture media that would be selective for identification or for allowing your anaerobes to grow. Hindi lang siya mga ordinaryong culture media. So, dadagdagan mo siya kasi you are suspecting for the presence of those anaerobes. Anyway, when you happen to receive like my pus, my mucus, or my clotted na specimen or clotted, so yun ang gagamitin. Try to pick on that area. Like sa stool sample natin, di ba? So, if you have mucoid na stool sample, so madaming part na pwede magiging sample natin. So, for your guidance on what part are you going to select. So, pag may mga mucus or blood, so dun ka magpipick ng specimen mo as your sample for to process. Number 4 here would dictate a need for non-routine or additional testing. So, just like kanina dito. Like, another one is, nakakita ka ng fungi sa microscope, under the microscope, then kailangan mo mag-culture. So, i-culture mo siya sa fungal culture media as an additional na test. Okay, in order for you then to help here identify or recover what's really the one na present or pathogen present in your biological specimen. Okay, then we have also here the different type of your culture media, although we have a separate topic for this. So the first one we have here enrich. Okay, enrich na culture media or culture media wherein they have an additional growth enhancer for allowing the growth of your fastidious na organisms. Ay, wala pala. Fastidious organism here, itong mga maaarte na mga bacteria. They do not, they have another special requirements for their growth. Hindi lang mga usual na growth requirements. So, kailangan mo silang pakainin ng kanilang mga special growth requirements. Those are fastidious na mga bacteria. Okay, so your culture media become enriched. If you try to add blood, if you add dye, if you add antibiotics to your culture media, it become an enriched. Example for that, we have your sheep blood agar plate. Your sheep blood agar plate, so meron siyang blood na naka-incorporate. Your chocolate agar, wala siyang chocolate Ang naka-incorporate dito is still your blood. Only that, try to heat mo ang blood into higher temperature until na magiging chocolate brown color siya. Okay, so it's still being incorporated with the blood but not your chocolate. Differential culture media, on the other hand, would help you then to differentiate between the colony characteristics of your bacteria. Example for that, we have your maconchi. Maconchi agar would help you differentiate between your lactose fermenter and your non-lactose fermenter. For the lactose fermenter, maconchi appear to be pink na colony. Ang mga non-lactose fermenter natin ay mga colorless. Therefore, able to differentiate based on their lactose fermentation capability as to their colony color, making this one as differential. Phenyl ethyl alcohol, paano siya magiging differential? This would differentiate your organism naman based on their hemolytic reactions. Okay, we'll discuss na lang mga ganyan hemolytic reactions like alpha, beta, gamma, mga ganun. Another one, we have your selective. Selective culture media would allow the growth only of one specific na organism, but at the same time inhibiting the growth of the other organisms. So for that, we have your Thayer, Martin Lewis, our selective media for your Neisseria gonorrhea. It will not support the growth of other organisms. Then we have also here other culture media. We have enrichment broth. Okay, when speak about broth media here, so they are so type culture media wherein there, this is a liquid na culture media. So wala siyang solidifying agent, wala siyang agar. So enrichment broth here in the form of your selenite F. What make this one enrichment? Because nag-add ka ng selenite F, which is your dye. Okay, that's right. Inhibit here the growth of your lactose fermenter. It would allow the growth of your non-lactose fermenter. So, broth here, another broth media in the form of your thioglycolate. Again, they are liquid. Hindi sila naka-solidified, like your agar. Okay? Okay, then we have here your specimen preparation. So, we have here the process of your concentration of your specimen. So, like in the case of your body fluids, diba, when you are having those body fluids, So you are receiving specimen that are, the volume is sobrang dami, wherein you just be recovering dapat lang ang particular na pathogen. So you can recover that one in a larger volume na specimen by centrifugation. Okay, we have here the centrifugal speed and time to 3,000 G-force. This is your relative centrifugal force. This is not RPM, revolution per minute. Magkaiba ito. So that's for 20 minutes. So after centrifugation, so your microorganisms try to settle at the bottom. They become your sediment. So ang sediment natin, try to decant and then try to collect the sediment. Yun ang ipiplate natin or nilalagay natin sa ating culture media or inoculate natin. Thus, give you a higher chance of recovering your parasite. Your bacteria, I mean. Another one, we have here the filtration. So, you know naman how the filtration works, diba? So, it depends on the pore size. So, if your bacteria would have yours bigger na pore na size compared to the pore size of your filter paper, will be trapped in your filter paper. Most likely, we're using Nalgene filter paper. So, after filtration, okay, so you can inoculate here your filter paper on the culture media or you can scrape this filter paper and the one you're going to inoculate in your culture media. On the other hand, we have tissues. So you need to homogenize your tissue here by your grinder. The problem with the grinder, there are some bacteria that might die if you try to grind. So pinaka-safe, you can cut into smaller pieces na lang with your scissors and your forceps. Okay, then we have here the process of your isolation. So there are ways, the different isolation technique here or inoculation technique. The first one, we have your general purpose streaking technique or you call it once your quadrant streaking. So this will provide you a semi-quantitative bacterial count, colony count. So the procedure for that, first, okay, parang you try to divide into 4 quadrants, parang ganon. You start here, so kukuha ka with your inoculating needle or loops from your specimen, then try to put here, small volume of that, and then try to streak. So pag ganon na siya, ganon. Okay, then rotate mo siya. So make sure na mahagip itong part na to para magkaroon ka ng specimen for the next quadrant. Rotate mo siya ulit. Okay, so that's how it works. And therefore, that would allow you then to recover here or isolate your pure colony. Usually, yung pure colony natin dito sa fourth quadrant. So, may mga mga isa-isa na lang na colony that become your pure colony. Another one, a streaking technique here, we have your quantitative. Okay, this is here for your urine culture and sensitivity for your bacterial count in your urine. So, it's being done here, so pag ganun lang siya. Okay, back and forth lang, passing through from one quadrant, the half quadrant to the next. So, it become quantitative because we are using here loops na calibrated. Okay, we have here the yellow na calibrated loops with the volume 0.01 ml. So, it will able to collect here 0.01 ml of your urine pag itong ginamit mo. So, parang ganun siya. Okay, so lalagay mo lang doon. So, ang content nito is 0.01 or the blue one, 0.001 ml. So, that would allow you then to measure the count and then try to report that one as colony forming unit per ml. Then we have your incubation. You need to incubate your culture media with the following temperatures. Okay, for the fungi, it's being incubated at 28 degrees Celsius. For the bacteria, it should be 35 to 37 degrees Celsius. We set our incubator at that temperature. But most likely for the bacteria, we are incubating that one at 35 degrees Celsius. Okay, we have here the gas requirements. Okay, aerobic organism here would require 21% oxygen. And we have also here your 0.03% carbon dioxide, incubated one for 2 to 3 days. Okay, your anaerobic on the other hand, so again, anaerobic walang oxygen dapat because oxygen is toxic to them. So we have here 5 to 10% of the hydrogen gas and carbon dioxide, 80 to 90% of your nitrogen. Wala siyang oxygen kasi again, toxic sa ating anaerobes ang oxygen. That incubated one for 5 to 7 days. Capnophile, so we have 15% oxygen, 5 to 10% carbon dioxide. Microaerophile, so we have here your 5 to 10% oxygen and 8 to 10% na carbon dioxide. Okay, those are the gas requirements. Okay, then we have here the culture workup. So these are actually the questions that would help you to correlate if what is really you're able to isolate in your organism or in your specimens really the one you are expecting, or is that just a contaminant? The first one, we have what's the source of the specimen. So if you're working in the microbiology laboratory, you know already much of that kung ano bang makikita sa, like if the specimen is sputum, ano bang mga usually makikita natin na bacteria. Second one, does the source have normal biota or it is sterile? So we must be very careful here with the mga specimen or site wherein mayroon silang mga normal microbial biota. So pag may mga normal microbial biota here, so baka yun ang na-isolate mo. So you need to identify that one. Or is that a sterile na site? Pag sterile ang site, dapat walang bacteria. So pag or magkaroon ka ng growth on that sterile site, mean to say, okay, that organism, the one causing the infection. Third one, what are most likely the pathogens? So again, so what I'm saying. So ano na-expect mo dapat na result. Fourth one was the colonial morphology. You could correlate that one. So since you're expecting, for example, Staph aureus, dapat small, mga colony lang dapat. So you need to correlate that one. Number 5, what media is demonstrating the growth? So again, all of that would help you then to really correlate and becoming confident here that what you are really isolating is really that organisms based on the several factors. Then we have here the result here, positive result that should be eventually be relate to the physician immediately because this is life-threatening. So first one, positive for the blood culture. So may bacteria sa blood ni patient. So dapat it needs to undergo here medication at an earlier time. CSF, positive for the gram stain. So meningitis ito. We have here staph pyogenesis parasite. Number 4, we have positive for the acid fast bacilli. So may tuberculosis ng patient natin. It's highly infectious ang patient natin. And number 5, we have also here the gas gangrene. In the case of your Clostridium perfringens. So again, those are mga toxic and life-threatening na mga conditions wherein you need to relay the result immediately for not only for the protection of the patient but as well as for the other people around, even mga health workers. Okay, so thank you.